Hello and namaste everyone. In this video I am going to show how to find the root of a given equation by using bisection method. For this, first of all, we create a Fortran editor file starting with the terminal, and just go to the desktop, we are just making a folder named bisect and change the directory to the folder just created, and we create a file named bisect1.f90 and bisect1.f90 and start editing with the file. So starting with program, and let's name it as bisection method. This program finds the root of equation f of x equals to x square minus 3. We just described what our program is going to do, and now what we do is just mention the interval. Just state the value of a. Let's fix it as 1, and for b let's mention it as 2, and now tolerance, the tolerance label, let's keep it as 0.01. this is just the tolerance. This tolerance basically helps to find our results under the desired value of accuracy. In bisection method, if the tolerance of the iteration is less than tolerance, then we are said to have our root under the desired value of tolerance. So if f of a and f of b, the product is less than 0, then print star comma I a b c f of a, f of c, and initial tolerance given by tol I, iteration tolerance given by tol I. Now we use do loop. Do I is equal to 1 up to 50, then c equals a plus b, b by 2, and tolerance of iteration is equal to absolute value of b minus a by 2. Now again print. Now we just want to format our values. So what we do is, instead of print star comma, we just write I2. This is gonna print integer with 2 characters and 6f 10.4. 6f 10.4. What this 6f 10.4 is going to do is, it just formats our results displayed on the screen with 10 characters, 4 characters after decimal. Altogether, including the decimal point, we can display 10 characters for a desired value of the result to be displayed. So for I, we are going to display 2 characters, just stated by I2. Then we have A, B, C, f of A, f of C, and iteration tolerance tol I. So altogether 3, 4, 5, 6, we have 6 values to be displayed which has the formatting of f10.4. So here we just wrote 6f10.4. So now if f of c is exactly equal to 0, then what happens is, then the exact solution of our equation is C. So we are just gonna print with similar formatting as stated above, A comma, give a bracket, A comma 2x comma f 10.4. The exact solution is C. Here this A just formats this string, and this 2x inserts a space of 2 characters in between this string and the value C, and 10.4 formats this C. So exit, and if then if tolerance of iteration is less than the stated tolerance, then what we have is we exit. Similarly, if f of A, f of C is less than 0, C is less than 0, then B is equal to C. Else, what we do is, if f of a, the product of f of a and f of c is less than 0, then the value b is replaced by c. That's what we have just stated in this program. Otherwise, if that's not the case, then we just change the bisection algorithm as a is equal to c. Then a is equal to c. If not, then we just end. And if and do else. If that's not the case, if f of a, f of c is less than 0, if this is also not the case, and if a is not equal to c, then what's gonna happen is, else we have another case, f of a, f of b is greater than 0. We can have this case if we do not have the previous cases. So print star comma no root found. Why? Because a and b are in the same site. Bisection method works only if the product of f of a and f of b is less than 0. But if f of a and f of b is greater than 0, then we cannot find the root. So we have just written like this. Then, and if print a comma 2x comma f 6.4, we have formatted our answer to be altogether of 6 characters in length, 4 characters after the decimal. So according to our formatted statement over here, we are gonna get the results. The root is C, and program bisection method. Here we have just missed one input to be given. What is that? Is we have just missed our function. It is f of x is x square minus 3. This is our function, and hope everything is correctly written over here. If there are errors can be seen after compiling and executing in terminal. If not, we can get our results. Let's save it. Finally go to the terminal, the Fortran bisect 1.f90. Yes, there are no any errors. Now just execute it, ./a.out. So after 7th iteration, we have received our root as 1.7266. 1.7266. This is how we can find the root of a given equation by using bisection method. Thanks for watching my video. In the next video, I am going to show how to find the root of the same equation using Newton-Raphson method. Now I am going to use Newton-Raphson method to find the root of the same function f of x is equal to x square minus 3. For that, let's create a zedit file. This program finds the root of f of x is equal to x square minus 3 using Newton-Raphson method. So let's start with program. Newton-Raphson method. F of x equals to x square minus 3. This is the function. Similarly, f of dx is equal to, now this is the derivative. We need to find the derivative of the above given function. The derivative of x square minus 3 is twice x. This is the derivative of the function. Now tolerance. The tolerance value, let's keep it as 0.001, and for initial value of root, let's guess it to be something like 2. Now what we do is we just use do loop. Do I equals to 1 up to 50th iteration. The iteration formula, Newton iteration formula, is xe, the guessed value of root, then f of xe by f of derivative of xe. Now error is absolute value, iteration value minus initial value by initial value, the guessed value. If error is less than the predefined tolerance, then xs is equal to xi. Then the iteration values will be the root. If not, what will be is we iterate to the next value, and if and do, then finally we print. We format this one. The first one, that is A, is for string, This 1x is just to insert the spacing between the string and our final answer. Then we format our desired answer to 6 characters including the decimal. So we have 4 characters after the decimal point. 1 itself is the decimal and 1 is prior to the decimal. That's our formatting of the answer. Then the root is something similar in the way xs. In program, Newton-Raphson method. So what we did is we just wrote the given function, we found the derivative, we assigned our tolerance, we just made a guess of the root to be 2, and we use do loop. This is our iteration formula. Then error occurring in this formula is the absolute value of iterated value minus guessed value by guessed value. Then if this error is less than our tolerance, then xs is equal to xi. This xs is defined as our root. Xi is this one obtained from the iteration formula. Else this value xc itself is our root. Then if it is our root, then what we do is we end the conditional looping, then we just end the do looping, then finally print our answer, then we end the program. This is all what we do. Now save it and just compile Fortran 1.f9t /a.out. The value is similar to the one obtained from above. It's 1.7266. After 7th iteration, it's 1.7321 for the same function. So what we saw from these two methods is bisection method is somewhat longer method. It requires just our interval, proper fixation of interval, where we can find the root and tolerance value. We assign the tolerance value. Here we do not need derivatives. In bisection method we do not need derivatives, but in Newton-Raphson method we must know how to find the derivative of the given function. It's somewhat faster than the bisection method. The algorithm is a bit faster. The answers are similar.